Hello students, welcome you all in this next video where we are going to solve 4-mark question from section C physics of sample question paper class 10 for the year 2025-26 for CBSE board. So already I have uploaded the video of section A biology and section B chemistry. Visit my channel. If you are not still subscribed my channel, please consider subscribing my channel so that you will get the notification of all uploaded video. In this video, I am going to start with 4-mark question of section C physics. So let's start with the question. So in this 4-mark question, we are going to start with question number 38. The above image is that of digital single lens reflector, that is nothing but a full form of DSLR, DSLR camera. You maybe have heard DSLR camera word. So this DSLR, it is the short form and the full form is digital single lens reflector. Because it has a single lens, it is called SL, single lens camera, which are used to take high resolution photographs by professional photographers. The second image of the above two is schematic diagram of how an image is formed on the sensor of the camera. Based on your understanding of the lenses, answer the following question. So this is the main explanation which is given. So this is called as a DSLR camera, and once the photo is captured in this camera, how that photo will capture, what is the main working in the camera, that is given in the second diagram. So you can see here, so this is the lens which will be there in this DSLR camera. So you can see this lens is nothing but it is a convex lens, and whatever light rays are coming from the object, so these are the light rays which are going to come from the object. They enter into the lens, here they will refract, and here we are going to get the image. So you can see this is the image. So we are getting inverted image and it is on the other side of the lens. So based on this information, we have to answer the following question. So we will start with question A. What type of lens is used in the DSLR camera shown in the image? Very simple question. So here there is a lens which I told you, and this lens is which lens? It is a convex lens. Therefore the answer is convex lens. Second question, that is B. What type of image is formed on the sensor? So you can see here, I told the image is on the other side of the lens, therefore it is real. And you can see if it is real, it will be inverted. So therefore the nature of the image is real and inverted. So these are the two questions from this. Now remaining question we will solve on the next page. Now the next question, that is C. Actually in this we have an internal choice. There are two questions, one is C and one is D. Out of these two, any one you can solve. Both are numericals. And first we will see C. A photographer is using DSLR camera with a lens of focal length 50 mm, means 50 millimeters. So focal length is given to take a close-up photograph of a small object. The lens projects an image onto the camera sensor that is located at 60 mm behind the lens. So you can see the lens project an image. So we are going to get image behind the lens, and what is the distance of this image from the lens? It is 60 mm. So image distance is given. While reading, you have to read it very carefully. You will understand what all given, and then it will be easy to solve the numerical. So we have a image distance, it is 60 mm behind the lens. Calculate the object distance. So here we have to calculate object distance, that is the distance between object and the lens. Very simple numerical. We have focal length, we have image distance, and we have to find out object distance. So we can use lens formula to solve this numerical. So first we will write what all given, and then we will write the formula and substitute the values. So answer, as I told, first we will write what all given values. So given we have focal length. Focal length is how much? It is 50. So I'll write 50 mm. Focal length is 50 mm. Now we have to think it should be taken positive or negative, because signs are very important in case of reflection and refraction. So according to the sign convention rules, now this is our convex lens and this is the principal axis. The rays which are coming, they will hit the lens and refract like this. See, they will refract like this, and this is called as focus. This is optical center, and this distance is called as focal length. and somewhere here there will be our object, and on the other side we are getting the image in case of this given question. Now see, according to sign convention, whatever values are going to measure on the left hand side, this is left hand side, all should be negative. Whatever distances we will measure on the right hand side, so this is the right hand side, and all should be taken positive. This is according to sign convention. If we see this, where we are getting focal length, we are getting focal length on the right side, therefore it should be positive. So I took 50 millimeter. Then we have image distance. So what is the symbol of image distance? It is V. V is equals to how much it is? 60 millimeter. Image in the question, it is formed on the right side. Therefore, this also we should take positive. So 60 millimeter. And what we have to find out? Object distance, that is small u. So I'll write it here question mark. Now we are going to write the formula. Which formula we are going to use here? We are going to use length formula. So I'll write it here. According to length formula. So what is the length formula? 1 by f is equals to 1 by v minus 1 by u. This is the formula. Now substitute all the values. Now before substituting the values, you have to rearrange the formula. We have to find out u here. Therefore, by rearranging, we will get 1 by u is equals to 1 by v minus 1 by f. Now the formula is ready to substitute the value. So 1 by u is equals to how much we have v? We have 60. So I took 60 minus it is 50. Now this 60 and 50 we have to take the LCM of these both. So how to find out the LCM? So let me find the LCM on the other side. So I'll write it here 60. Here I'll write 50. So I will take prime number 10. 10 6 the 60. 10 5 the 50. Then I will take 5. 5 1 the 5. 6 as it is. Then I will take 6. 6 1 the 6 and 1 as it is. Now here you can take 2 also. With the help of 2 you can first divide and then you can go on increasing. I have started with the 10. So now to find out the LCM, multiply these all. So LCM is equals to 10 into 5 into 6. 10 5 is the how much? 50 into 6. So how much you'll get? 6 0 is 0, 6 5 is 30. So we will get 30. So 30 is the LCM of this. Now substitute the LCM. 1 by u is equals to the LCM is 300. So I'll write 300. Now you can see 60. How much is the 300? That we have to calculate it first. So here 65 is 300 and 56 is 300. If you see 5 1s are 5 minus and here it will be 6 1s are 6. Now what we can do it here? So now solve it here. 1 by u is equals to 5 minus 6 will be 1. The bigger number is 6, therefore minus 1 divided by 300. Now reciprocal u is equals to minus 300 mm. And this is the value of object distance. And in this numerical they have asked the same thing. Calculate the object distance, that is distance from the object and the lens, and it is minus 300. Now you can understand negative sign indicates that our object is present on the left side of the lens. So this is the answer for question C. After this we are going to move with question D. Now the question D is, a photographer is using DSLR camera to take a picture of flower. The flower is positioned 150 millimeter away from the camera. So we have a object distance. It is 150 millimeter. The actual height of a flower is 80 mm. So we have given the height of a flower. So height of the object we have, that is 80 mm. And the image height formed on the camera sensor is measured 20 mm. So we have image height also. We have object height and we have image height. Calculate the focal length of the camera. So we have to calculate focal length of the camera. So first, as I told, first we will write what all given and then we will think which formula we can use to find out the focal length. So here I'll write given and what all is given. So you can see in the question we have the flower position. So we have a object distance. Object distance is denoted by the letter small u. So I took small u and object will be always placed on the left hand side. Therefore, this value we should take minus 150 mm. Remember, left side all the values should be in negative. So I took minus 150 mm. Then we have a height of a flower. So it is nothing but object height. So object height is denoted by HO. So I'll write HO is equals to 80 mm. So I'll write 80 mm. Now see here, object will be always on the principal axis upside. So whatever height are upside, above on the principal axis, those are in positive. And whatever height will be below principal axis, all should be negative. So we have seen. So in case of DSLR camera, whatever, if the flower is somewhere here, imagine if the flower is here and whatever the light rays will pass and we are going to get the image, if that image is formed on the other side, then this is the height and this height should be in negative, this height should be in positive. Why positive? Because above the principal axis and this is below the principal axis. Therefore, HI, height of the image, HI, that is 20, it should be written in negative sign, 20 mm. So remember, I hope you understood why I wrote minus 20, because image is inverted. So I have written minus 20 mm. And what we have to find out? We have to find out focal length. So focal length means F. F is equals to question mark. Now if you see this sum in this numerical, we have to find out F. And to find out this F, we have to use length formula. And in length formula, if you see, 1 by F is equals to 1 by V minus 1 by U. This is the formula. And we have U, but we don't have V. At least two you should know the values. Either FV or VU you should know. Then third we can find out it easily. But here, we don't know F, we don't know V. We have only U. Then with this data, you cannot find out focal length. So first thing what you have to do, first try to find out the answer of V, that is image distance, and then you can find out focal length by using this V. And to find out the value of V, we are going to use the value of image height and object height, that is by finding magnification. So I will use magnification formula, use magnification formula to find V. V means what? Image distance. So let's start. Use that formula. So what is magnification? Small m is equals to HI divided by HO. So substitute the value in this. M is equals to, what is HI? Minus 20 mm. And what is HO? It is 80 mm. So now see what happens. 20 ones are 20 and 24s are 80. So now what we can write? Small m is equals to minus sign as it is 1 by 4. This we can still solve and we will get small m is equals to minus 0.25 mm. I hope you understood this. If you divide 1 by 4, you will get 0.25 and the negative sign is as it is. So I wrote magnification is equals to minus 0.25 mm. Now we know the magnification. Use this magnification value and find out the value of V. So here I will write use the value of magnification and use the value of magnification. I'll write to calculate that is image distance. Like this also we can write image distance. Image distance means nothing but what? It is small v. So what is the formula? We have the relation that is m is equals to v divided by u. So now we can substitute the values in this. Already we know the m. So what is m we have got? M is equals to minus 0.25. And what is u? U is equals to minus 150. These are the values which we have. And now substitute these values to find out V. So rearrange the formula. We want to find out V. So V is equals to M into U we can write. So V is equals to, what is M? Minus 0.25 into, what is U? Minus 150. So see here. Now when we multiply these both, what you are going to get? So divide this. 0 5 is 0, 0, 0 first one, then plus 5 5s are 25. I'll write it 5. 2 I'll write as it is. 5 2s are 10. 10 plus 2 is 12. So I'll write it 2. 1 here. 5 0 0 0. 0 and 1 will be 1. So next plus plus. Now multiply by 1. 1 5s are 5. 1 2s are 2. 1 zeros are 0. Now add these all 0, 5, 7, 3 and 0. Now see the decimal. Where you're going to get the decimal? Decimal is after two digits. This is 1, this is 2 and here is the decimal. Therefore 1, 2 and decimal will be here. And therefore the V value will be V is equals to 37.5 millimeter. And what about the sign? Negative, negative will be positive. Therefore positive sign. So here we got the answer of V, that is 37.5. We are getting positive means what? We are going to get our image on the right side of the lens. Now use this V, U and we can find out the focal length. So this we will solve on the next page. Now I'll write it here. Calculate focal length. Now first again we will write what all values we have. So we have U and U is how much here? Minus 150 millimeter. V just now we have find it out. We have got 37.5 millimeter. And what we have to find out? Focal length. So focal length is question mark. So which formula we can use? Use lens formula. Now what is the lens formula? 1 by F is equals to 1 by V minus 1 by U. No need to rearrange the formula because we want to find out F and F is on the left hand side. Therefore directly substitute the values. 1 by F is equals to 1 divided by 37.5 minus 1 divided by minus of 150. So first solve the signs. 1 divided by F is equals to 1 divided by 37.5, minus of minus will be plus and then it will be of 150. So this is the one we got. Now see, we have to find out the LCM of these two. But one number is in decimal and one number is without decimal. So it will be difficult to find out the decimal if it is like this. So what we should do? We should remove this decimal first. Remove the decimal, convert into a normal number and then we can take the LCM of this. Now how to remove the decimal? What we can do? Shift the decimal to the other side by 1 digit. Once you shift the decimal to the other side by 1 digit, right side, then on the numerator there should be multiplication of 10. See here. If you shift it by 1 digit, then there will be multiplication of 10. If you shift it by 2 digits, then the multiplication will be with 100. So now let me solve this first. So here I will write 1 by F is equals to 1 divided by 37.5. Sorry, if we remove the decimal first, it is 5 and here it will multiply by 10 plus 1 divided by 150. Now again simple way we can write 10 divided by 375 plus 1 divided by 150. Now what we can do it here? We can divide this first number and make it small and then we can take the LCM. It will be easy. So I'll divide it. So what I can do? 5 2s are 10. So here what are 5 7s are 35 and 5 5s are 25. So what I'll get the numbers? 1 by F is equals to 2 divided by 3. Sorry, now not 375. It will be only 75 plus 150. See, now numbers are very small. Now it is easy to find out the LCM of these two. 375 was very big number. It will be difficult to find out the LCM, but now it will be very easy. So I will take one side 75 and one side I'll take 50. Now I'll take the prime number 5. So 5 1s are 5, 5 5s are 25, 5 3s are 15, 5 zeros are 5. Again I'll take 5. So 5 3s are 15, 5 6 are 30. Now I'll take 3. 3 1s are 3, 3 2s are 6. And now the last number is 2. 2 1s are 2 and 1 as it is. So what is the LCM? We are going to get 5 into 5 into 3 into 2. So what we will get? We are going to get 150. So this is our LCM, that is 150. Now substitute that LCM into this sum. So here I'll write 1 by F is equals to, the LCM is 150 I'll write it as it is. And now what will happen here? 75 2s are 150, 150 1s are 150. So you will get 2 2s are 4. So 4 plus 1 divided by 150. And this will be 1 by f is equals to 5 divided by 150. This we can again divide it, cancel it by 5 table. 5 1s are 5, 5 3s are 15, and 5 zeros are 0. So what we can write? 1 by f is equals to 1 divided by 30. Reciprocal f is equals to 30 millimeter. So here the focal length is 30 millimeter. You can see the sign, it is positive, and we know for convex lens focal length will be where? It will be on the other side. This is the focal length, and on right side it will be positive value, and this is a positive value. Therefore the focal length of this question is 30 millimeter. So this is the answer for question D. So as I told, here there is a choice of C and D. Whichever you feel easy, that question you have to attempt. No need to attempt C and D both, because you have a choice. And for this, what you have to do? You have to read the question, understand the question, and see it first. Are you able to solve the question properly? It may be C or it may be D. Whichever question you can solve it properly and clearly, attempt only that question. And whenever you solve, you have to focus on the signs in case of light reflection and refraction chapter. So if you like my videos and for more such videos, share my videos with your friends, comment your doubts which you have in this section, and subscribe my channel for more videos. Thank you so much.